In this video, we'll be going over the sorting algorithm selection sort, its characteristics, a demonstration, and the code implementation. Selection sort. It only swaps once when needed. This means that selection sort only swaps once per iteration and only if it is needed. It takes an array A as a parameter. In this example, we'll be using an array of integers. However, selection sort does work with larger amounts of data, such as linked list. It has the complexity of big O and squared. This is because the selection sort algorithm is made up of two for loops. Here is the algorithm for selection sort. As you can see, on line 2, we have our first for loop. On line 5, we have our nested for loop. Inside of the nested for loop, on line 6, we have the if statement, which will cause a switch only when necessary. Moving forward, on line 10 through 12, you can see this is where the actual swapping will take place. Here's a visual demonstration of what's going on. This is the algorithm for selection sort. To better understand what's going on, we will focus on the if statement, which is inside of the nested for loop. Here we have our array A and index smallest, which is the variable that will keep track of the smallest index, or in other words, the index which contains the smallest value. Since this will be the first iteration of I, index smallest is initialized to it. I is initialized to the first index, which is 0, meaning that index smallest is equal to index 0. On line 5 of the algorithm, you can see that j is initialized to I plus 1. This means j will always be one spot ahead of I, meaning that j is equal to index 1. We can now begin the comparison. Is a at j less than a at index smallest? Or is 15 less than 23? True, it is. This means index smallest will be set to j, which is index 1. Incrementing j, it now moves forward to the next index, and we can ask the same question. Is 1 less than 23? True, it is. This means index smallest will be set to j, which is indexed 2. Moving forward, j is set to index 3, and we ask the question, is 15 less than 1? False. This means nothing happens, and j increments. Now we have, is 30 less than 1? False. This means nothing happens, and we move forward. Now we have, is 8 less than 1? False. J increments, and now we have, is 3 less than 1? False. Now that we are at the end of the iteration, this means that we have found our smallest index, meaning that we will swap it, and that area will become grayed out, since j only reaches from indexes I plus 1, and with this iteration, I would be equal to 1, meaning I is initialized to 1. Now we start the process over. First we initialize index smallest to I, which is index 1. Now we set j to I plus 1, which is index 2, and begin the questions. Is 23 less than 15? False. This means nothing happens, and j moves forward. Is 15 less than 15? Not really. This means nothing happens, and j moves forward. Again, we have, is 30 less than 15? False. We move forward. Is 8 less than 15? True. This means we set index smallest to j, which is index 5. J increments, and now we have, is 3 less than 8? True. This means we set index smallest to j, which is index 6. Finishing the swap, as seen on line 10 through 12, that area is now grayed out, and we can move forward. Beginning with the next iterations means setting I to index 2. We set index smallest to I, which is index 2. We then set j to 1 above I, which is index 3, and begin again. Is 15 less than 23? True. This means index smallest is set to j, which is index 3. Moving forward and incrementing j, we have, is 30 less than 15? False. This means nothing happens, and j increments. Now we have, is 8 less than 15? True. This means index smallest is set to j, which is index 5, and then we move forward. And now we have, is 15 less than 8? False. This means nothing happens, the iteration is complete, we do the swap, and reset I. Setting index smallest to I, which is index 3, we can then initialize j, and begin. Is 30 less than 15? False. Nothing happens, and j increments. Is 23 less than 15? False, which means nothing happens, and j increments. Finally, is 15 less than 15? Not really. This means nothing happens, and we can now increment I, set index smallest to I, which is index 4, and set j to index 5. Moving forward, we have, is 23 less than 30? True. This means we set index smallest to j, which is index 5, and increment j. We now have, is 15 less than 23? True. This means we set index smallest to j, which is index 6, swap, gray out that square, and increment I. Now we initialize index smallest to I, which is index 5. Is 30 less than 23? False. This means nothing happens, and the array is sorted. Next we'll go into the code implementation for the algorithm. Here's the coding implementation. First, I'm going to create a class. Then I'm going to create my main. Now I'm going to initialize an array with the values I used in the visual demonstration. Moving forward, I'm going to actually create the algorithm in its own method. The only parameter it needs is the array. Now I'm going to create the first for loop. Inside of the first for loop, I will initialize the index smallest variable. This variable will be assigned to I. Next, I'm going to create the nested for loop. J is equal to I plus 1. Inside of the nested for loop, I will have the if structure. If A at J is less than A at index smallest, then index smallest is equal to J. Outside of the if statement and outside of the nested for loop, I will create the swap. Here, we need a temporary variable, so nothing gets lost when we swap. This will be assigned to A at I. A at I will then be equal to A at index smallest. Then A at index smallest will be equal to the temp. Now all I need to do is create a method call, pass the array, and now I just need to print. I will be removing the ln. This means everything will print on the same line. A at I concatenated with a space, so that we can read it easily. Making sure to finish the line, I will system out print ln to eat the last line. Now it's ready to be compiled and run. As you can see, it is sorted. I hope this was helpful, and happy coding!